So we have we call it as data abstraction or data three-level schema architecture. So physical level or physical schema is the low-level abstraction that describes how data is actually stored in a database, in a disk file, or in a memory, right? So the physical level also, it also describes the data structures that are used to store the data, right? So what data structures are used to store the data and how it is actually stored in a physical storage, right? So it is given by a physical level or physical schema. And the next level of abstraction is going to be logical level or logical schema. So it describes what data is stored and what is the relationship that exists among the data, right? So for example, you have some student details, right? So you may have student ID, name, age, contact number, contact mail ID, and so on. So what data is stored and what is the relationship that exists among the data is given by logical level or logical schema, right? So it describes the entire database in terms of small number of relatively simple structures, right? So physical means how the data is stored and what data structures are used to represent the data. And in the case of logical schema, we describe what data is stored and what relationship exists among the data. And finally, we have external schema or view level. So it describes only part of the entire database, right? So many users of the database system do not need all the information, right? So they need only to access a part of the database, right? So a person working in finance department will be he will be need he may need information only about the financial details of an organization, whereas a person working in HR department may be looking only for like salary, benefits, and training details of an employee in an organization. So right, so we need to provide different perspective view for different users who are accessing the system, right? So the view level of abstraction exists to simplify their interaction with the system, right? So this is how we define the three schema architecture of a database, right? So we have physical schema means what data is stored, right? What data structures are used to represent the data, right? So how the data is stored in a database and what data structures are used to represent the data, it's given by physical schema. And logical schema, it represents the relationship that exists among the data. So what relationship exists among the data that is being stored in a database, right? And the highest level of abstraction is given by external schema or view level, which describes only part of the entire database, right? So once you know this physical schema, logical schema, and external schema, you need to know 2 points, 2 concepts. One is going to be physical data independence and the other is going to be logical data independence, right? So what do you mean by physical data independence, right? So in the case of physical data independence, I must be able to change the storage details of a particular database without rewriting the application programs. It's known as physical data independence, right? So I should be able to make changes in the physical level without making changes in the view level or external schema. It's known as physical data independence, right? So initially I may have stored my database in a main memory. Over a period of time, I would have transferred a particular database into a disk, right? So the thing is that whenever I make some changes to the physical schema of the database, it should not result in rewriting the application programs that access the database. It's known as physical data independence. And the next is like logical data independence. So logical data independence means I should be able to logically add some more attributes to a particular database. I should be able to add attributes or fields in a database without causing an application program to be rewritten. It's known as logical data independence, right? So for example, once you join the institution, we get some information from the student, right? So probably once you leave the institution, once you complete your course, we'll have some details about the placement details of a student, right? So where you are being placed and so on. So I should be able to add some attributes and their corresponding values in a particular relation without causing the application program to be rewritten. It's known as logical data independence, right? Right. So for example, we want to add some more details about a student, right? Right. So initially we have only contact number. Now we need to include your contact email ID of a particular student and so on, right? So we should be able to add some new attributes in a relation without causing the application programs to be rewritten. It's known as logical data independence, right? So this is about the three schema architecture or data abstraction, right? So data abstraction means you are going to hide the internal implementation details from the end user, right? So end user of a database should not be worried about how the data is internally stored or what data structures are used for representing the data, right? So here physical schema or internal schema means, right? So it deals with how the data is actually stored in the database and how in turn it is being stored in a memory or in a disk drive, right? So it also describes the low level data structures that are used to represent the data. It's known as physical schema or physical level. So logical schema means logical schema or logical level means it defines the relationship between the data, right? So what relationship exists among the data, right? So what's the data type of a particular variable and so on. It's known as logical schema. And external schema or view level, it gives different perspective view of the same database to different types of users who are accessing the database, right? So many users of the database system may not need all the information, and they may need to access only part of the database, and this uh, rights are being given at the view level or external schema, right? Right. So we have done with physical data independence and logical data independence. So physical data independence means we are going to make changes in the storage structure of the database without causing the application programs to be rewritten, or without making changes in the view level. It's known as physical data independence, right? So we are going to store the internal schema or physical schema, which deals with the storage structure of a database. Whereas in the case of logical data independence, we are going to make changes in the logical structure of a relation, right? So I'm going to add some attributes, or I'm going to remove some attributes in a particular relation without causing the, without making any changes in the external schema or view level. It's known as logical data independence, right? Right. So for example, you have an instructor record, right? So this is an example for a database, right? So an instructor is characterized by a unique primary key ID of type character data type, right? Name is again a character data type. Department name is going to be character data type of 20 characters. Salary is a numeric data type, right? So it's like a floating point data. You have totally eight numeric values with 2 points after the decimal, right? Two numbers after the decimal, right? So this is how we can visualize a data in a record in a database, right? So you have instructor ID, name, department name, and salary, right? So so the database system hides many of the low-level low-level storage details from the database programmers, right? So data abstraction, we are going to hide the internal implementation details of the data from the users, right? So database administrators, on the other hand, they may be aware of the circuit details of the physical organization of the data, right? Maybe only DBA, they may be worried about how to store the data, whether to store it in a memory or in a disk file, right? Uh, So they take care of the storage details of the database, right? So at the logical level, each record is described by a type definition, right? So each record, you have some type definition for each and every field, right? Whether name is going to be character, data type, and the interrelationship between the records are also defined well, right? So for example, I want to represent a student in the form of a relation, right? So student ID is going to be character, student name is going to be character, right? Age is going to be integer, right? So we can have some field definition of each and every attribute, and the relationship of interrelationship of the record type is also defined well, right? And finally, view level, several views of the databases are defined, and the database user sees some or all of these views, right? So we can create views for different users working in different departments, right? So in addition to hiding the details of logical level of the database, the view level also provides a security mechanism to prevent users from ascertaining certain parts of the database, right? So different users will be given a different perspective view of the same database by means of views in external schema, right? Right. So the physical schema deals with the physical storage details of the database, which may be in a main memory or in a disk file. And the logical level, it describes the type definition of the different records in a database. And it also defines the interrelationship of the records, right?